Hi everyone, today's goal is to solve one-step equations. Now remember, an equal sign means that both sides of the equal sign have to be in balance. So think back. I know I've done this before with you guys if you had me for 7th or 8th grade. But the equal sign's here in the middle, and this is our balance scale. So if I take away 1 from here, and for whatever reason I have to change the page and come back to it and then it works. I also have to take away a blue 1 from this side in order for the scale to be in balance. Now if I add a blue back to this side and I don't do anything to the other side, our scale is going to be off balance, so it's really not equal anymore. But let's say I ran out of blue ones on this side. Instead, I can add 3, 4, 5 little yellow ones, because 5 little yellow ones equals the same thing as a blue one. So as long as I put a blue one here and 5 yellow ones on this side, our scale's still going to be in balance. We can still use an equal sign between the two of them. So for an equation, whatever you do to one side, you have to do to the other side. No ifs, ands, or buts. In order to do that, we have a couple of different properties, again, for you to learn, love, and memorize. The first is the additive property of equality. And that says if A equals B, then A plus C equals B plus C. So in other words, and we'll do it with numbers, sorry for the writing, if we let A equal 10 and B equal 7 plus 3, which we know is another way we can say 10, and let C equal 5. Well, if we have 10 plus 5 on the left side, we then have to take 7 plus 3 and add 5 to it as well. So whatever we do to the left, we have to do to the right. The next property we have is quite similar. It's the subtraction property of equality. And it says if A equals B, then A minus C equals B minus C. Here's our example again. A equals 10, B equals 7 plus 3, and C equals 5. So if we subtract 5 from 10, we also have to subtract 5 from 7 plus 3. The next property, I'm going to move this over, is the multiplication property of equality. Are you seeing any patterns yet? Can you guess what this one's going to say? If A equals B, then A times C equals B times C. So if A is 10, B is 7 plus 3, and we let C equal 2 this time, 10 times 2 has to be equal to 7 plus 3 times 2, because we said 10 was equal to 7 plus 3. Whatever we do to one side, we have to do to the other. Take a guess at what our last property is going to be. Hope you're all saying the division property of equality. By now you can probably figure out what that says as well. If A equals B, then A divided by C has to be equal to B divided by C. And you need to remember, C cannot equal 0. We are not allowed to have zeros in the denominator. By now you should be able to explain why. Here's our example again in numbers. Let A equal 10, let B equal 7 plus 3 again, and C is going to equal 5 in this case. So if we start out with 10 equals 7 plus 3, and we divide 10 by 5, we need to also divide 7 plus 3 by 5. These properties allow us to isolate a variable and solve an equation. So here we have x minus 3 equals 10. In order to get x by itself, we're going to add 3 to both sides. And x is equal to 13. And this would be what property? The additive property of equality. A plus 17 equals 20. in order to get a by itself, we're going to do the opposite of adding, which is subtracting. The subtraction quality of equality, property of equality, states that if we subtract 17 from the left side, we have to subtract 17 from the right side. And in this case, we would get a is equal to 3. b minus 13 equals 40. Well, we can add 13 to both sides to get b by itself. Remember, whatever we do to one side, we have to do to the other. And b is equal to 53. You should always go back and double check. Plug in 53 for b. 53 minus 13 does in fact equal 40, so we solved it correctly. A few more examples. Write them down, and then I'm just going to show you the answers. Negative 5 plus a equals 10. C minus 3 equals 49. A plus negative 7 equals 105. Stop the recording until you figure them out. And here's your answers. A is equal to 15. C is equal to 52. And at the bottom, A is equal to 112. Here's another example I want to walk you through. A divided by 5 is equal to negative 2. To undo the division, we're going to multiply both sides by 5, and we get A is equal to negative 10. Now, the fun part is always when we toss a fraction in here. 3/4 times b equals 9. In order to get this coefficient equal to 1, we want to multiply both sides by the reciprocal. So over here, we're going to multiply the reciprocal, which is 4/3, to 3/4 times b. And then because we multiply this side by 4/3, we need to multiply the right side by 4/3 as well. These are going to cancel out and go to 1 times b. And here we have 9, and don't forget the 1 underneath it. Okay, there's always a 1 underneath our whole numbers or integers, times 4 over 3. We can cross cancel out. 3 goes into 3, 9. I'm sorry, 3 goes into 9 3 times, 3 goes into 3 once, and then we end up with 3 times 4, which is 12, over 1 times 1. And we can write that just as 12. Okay, here's another example with a fraction in front of the variable. Again, we're going to multiply both sides by the reciprocal of 5/2, which in this case would be 2/5. This side is going to go to 1 times x. Because we multiplied the left side by 2/5, we need to multiply the right side by 2/5. Cross cancel here where you can. 5 goes into 5 one time. 5 goes into 15 3 times. And we end up with 3 times 2, which is 6. And on the bottom we end up with 1 times 1, which is 1, but we don't need to write that. Here's another example. 7/2 times y equals negative 3. To get rid of the fraction, we're going to invert it to 2/7 and multiply both sides by 2/7. The left side's going to cancel out and become 1. 1 times y is y. Because we multiplied 2/7 to the left side, we have to multiply to the right as well. There's nothing we can cross cancel here, so we have to multiply negative 3 times 2, which is negative 6, and then 1 times 7, which is 7. So y is going to equal negative 6/7. One final example, and it doesn't matter if your fraction and your variable are on the right side or on the left. We have negative 75 equals negative 5/6 times y. Here's our reciprocal, negative 6/5. We multiply both sides by it, because whatever we do to one side, we have to do to the other. We can cross cancel a bit on this one. 5 goes into 5 one time, 5 goes into 75, 15 times. Don't lose your negative sign though. Now we end up with negative 6 times negative 15, which is positive 90, over 1 times 1, which is 1. We don't need to write the over 1 here. We can just write it as 90. And then here, our reciprocal is going to cancel the 5/6 out and leave us with 1 times y. So our answer in this case is 90.